Imagine a car engine, but completely rethink its core. We're talking no crankshaft.
Yeah, that central piece that's been in almost every engine for, what, over 100 years?
Exactly. And today we got a great comment from one of you listening, pointing us towards a French inventor, Jean Morel.
Ah, Morel.
His work is making some serious waves, apparently even popping up on the podcast de Philippe. So we thought, let's dive in. What could these crankless engines actually mean for, well, the future of driving?
It's a really fundamental question. I mean, we're not just talking a small design change here. This challenges the absolute basics of how internal combustion engines have worked for ages.
Right.
That crankshaft, its whole job is turning that up and down piston motion into the spinning motion that moves the wheels. Getting rid of it. That's a huge leap. It could mean big gains in efficiency and, potentially a much smaller environmental impact.
Okay, so let's unpack that. Our mission today. Figure out what makes these crankless ideas so disruptive. Why Morel? Why now? We've been digging through Le Podcast de Philippe, technical articles, even some history.
Trying to piece it all together.
Exactly. So let's start with Jean Morel himself. He's the spark for today's dive. What's his story?
Well, from what we gather, Jean Morel is described as this really experienced, deeply passionate French engineer.
Okay.
And what's interesting is, he's at an age where many might be retired, but instead he's poured decades into this research.
Wow, decades!
Yeah, and he's apparently right on the edge of a major breakthrough in mechanics, really pushing boundaries.
Okay, this is where it gets really interesting for me. No crankshaft.
Yeah.
How does his engine actually work? And what specific problem is he solving that old school engines just can't?
Right. So Morel's engine uses some pretty advanced tech. It combines powerful magnets with very precisely controlled electric coils.
Magnets and coils. Okay.
Instead of a physical rod pushing a crank, the piston moves, and these magnetic and electric fields interact. They directly convert that linear up and down energy into rotational force.
So completely bypassing the mechanical link.
Exactly. No crankshaft needed to make that conversion. And the big win there is a really significant drop in mechanical friction.
And significant reduction in friction.
Yeah.
What does that mean in the real world? For a car or maybe even a plane? Because friction is just everywhere in an engine, isn't it?
Oh, absolutely. Friction is basically the enemy of efficiency. Every moving part in a regular engine rubs, creates heat, wastes power.
Right.
By taking out the crankshaft and all the connecting rods that go with it, Morel's design promises much less wear and tear. And crucially, a big jump in energy efficiency.
Okay.
In this era where everyone's focused on energy transition, using less energy directly means less heat, less internal resistance.
Yeah.
And that means fewer CO2 emissions.
Okay.
So for industries like automotive or even aerospace, where they're always chasing performance and lightness, this tech could really lead to cars and planes that are more economical, lighter, last longer, and importantly, have a smaller carbon footprint. It's a fundamental shift, not just tweaking things.
That sounds like a potential game changer, especially with climate goals being so central now. But where is this technology in the real world? Is it just theory, or are there actual engines running?
It's definitely moving beyond just concepts on paper. Morel's teams are apparently deep into extensive simulation testing right now.
Simulations, okay.
And these aren't simple models. We're talking incredibly complex simulations designed to really push the virtual engine to its limits. They're looking for stress points, durability issues, basically trying to break it virtually before they build it physically on a large scale.
So vetting it thoroughly.
Exactly. It's seen as more than just an innovation. Some are calling it a potential revolution for the internal combustion engine, really pushing engineering and material science. Of course, going from simulation to mass production is a huge step.
A massive step, yeah.
But that foundational work seems well underway.
What's really striking, though, is that this idea, getting rid of the crankshaft, it isn't totally new, is it? It feels like engineers keep coming back to this challenge, like it's some kind of holy grail. What's the history here?
You're spot on. The idea's been kicking around for, well, over a century.
A century.
Yeah. And the motivation has always been the inherent downsides of the traditional cranking connecting rod system. I mean, it works, it's reliable, but it's mechanically complex.
Right.
Creates a lot of friction, wear, and you lose efficiency because the connecting rod pushes the piston sideways a bit as it moves.
Ah, okay, those lateral forces.
Precisely.
Yeah.
So inventors throughout history have looked for clever ways around that, trying to get that linear motion turned into rotation more directly.
Can you give us a quick tour? What are some other notable attempts? And maybe why didn't they end up in, the car I drove here today?
Sure. Well, connecting it to the bigger picture, one of the earliest really significant ones was from an Australian, A.G.M. Mitchell. He patented his crankless engine way back in 1917.
1917, wow.
His design used something called a swash plate. Imagine a tilted disc spinning.
Okay, like a wobbly plate.
Sort of, yeah. The pistons push directly against this angled plate using these special tilting pads, and that converts their back and forth motion straight into the disc's rotation. It was actually incredibly clever.
Sounds ingenious.
It achieved perfect mechanical balance, apparently, and even demonstrated about a 10% improvement in fuel economy over engines back then.
10% better back then, so technically superior. Why aren't we all driving Michel engine cars? Seems like a classic story of great tech hitting a roadblock.
It really is, precisely. Despite being brilliant technically, it mostly failed commercially. There were a few reasons. The company didn't have enough money, struggled against the big players, there was resistance from the established industry, the not invented here problem.
Right, if we didn't make it, we don't want it.
Kinda, yeah. And maybe most importantly, fuel was just really cheap in the 1920s. There wasn't that strong economic push for a radical, more efficient, but probably initially more expensive engine.
Yeah, market conditions weren't right.
Exactly. But the principle wasn't totally wasted. It actually found a niche later in high-pressure fuel pumps for jet engines. So the core idea had value.
Fascinating how timing and economics can just overshadow good engineering. Are there more recent examples? People still trying this?
Oh, definitely. More recently, there's Maurice Saint-Germain, another French inventor, incredibly dedicated, apparently in his 80s now.
Another octogenarian innovator.
Right. He also developed a thermal engine concept without a crankshaft. His system uses a different mechanical trick, rotating eccentrics and synchronized gears.
Eccentrics, like off-center cams.
Yeah, think of it like that.
Yeah.
As the pistons move, they interact with these off-center rotating parts, which then drive gears to get that smooth rotational output. His design is promising something like a 15% boost in energy efficiency, plus less vibration and noise compared to traditional engines. It just shows how this problem keeps attracting engineers.
15%. That's even better than Michel's claim. Are there any other really different takes, maybe moving beyond pistons altogether?
Yes, absolutely. There's the quasi-turbine.
Yeah.
This came out of Quebec, invented by the Saint-Hilaire family, patented in '96.
Quasi-turbine sounds different.
It is, no pistons. It uses this articulated four-sided rotor that moves inside a specially shaped oval casing. This creates four chambers that constantly change volume as it rotates.
Okay, that's hard to picture, but sounds smooth.
The main advantages are its simplicity, fewer moving parts than a piston engine, no valves needed, very little vibration, and it's versatile. It can apparently run on compressed air or steam too.
Wow.
And they're also exploring something called photo detonation with it.
Photo detonation. Okay, that sounds incredibly futuristic. What is that, and why does it matter?
It really does sound sci-fi. Basically, instead of a spark plug starting a flame that slowly burns across the fuel-air mix, photo detonation uses precise laser pulses to ignite the entire mixture almost instantly, all at once, throughout the whole chamber.
A laser ignites everything at once.
Pretty much. This super fast, complete combustion means potentially very high efficiency, especially at lower power levels, because you're wasting less energy and unburned fuel.
Okay, I see.
For the quasi-turbine, using this laser-controlled combustion could make it a really efficient, compact power source. Maybe even an alternative to complex hybrid systems in cars someday. It's a whole different way of thinking about burning fuel.
Okay, so bringing this all together, we've got Morel with magnets, Saint-Germain with eccentrics, the quasi-turbine with its rotor and maybe lasers, and history like Michel's swash plate. They all seem to promise similar big benefits: efficiency, lower emissions, less friction. So the big question remains, why aren't they everywhere already?
That is the crucial question, isn't it? Why is this tech, which sounds so good on paper, still mostly stuck in labs or testing phases, sometimes for decades?
Yeah.
The sources point to some major hurdles, and they're not always just technical. For someone like Saint-Germain, it's that deep-seated reluctance of the big car manufacturers to invest massively in something so disruptive.
It's not just swapping out a part.
No, not at all. It means retooling factories, changing assembly lines, rethinking entire supply chains. They're comfortable with what they know, what's proven, and the sheer cost and risk involved in switching to a totally new engine architecture is just enormous.
It's a huge industrial and economic gamble for them.
Exactly. And even for Morel, where the simulations look good, making that jump to reliable, affordable mass production is always where the unforeseen problems crop up.
Right, scaling up is hard.
Definitely. And the Michelle story reminds us, even if your tech performs better, market inertia, existing infrastructure, financing, these things can stop a great idea in its tracks. These are systemic issues, not just engineering ones.
No, but still, the potential benefits for the environment, for performance, they feel so incredibly relevant right now, don't they, with climate targets and fuel prices? Isn't this the perfect time?
You'd think so. And these crankless engines really represent this long, persistent search for cleaner, more efficient power. Whether it's Morel's direct energy conversion, Saint-Germain's mechanical elegance, or the quasi-turbine's radical combustion, they're all fundamentally about maximizing the energy you get out of fuel and minimizing the waste. And that aligns perfectly with what the world is trying to do now. Cut carbon, build sustainable transport. They're trying to wring every last bit of efficiency out of combustion.
So maybe it's not a matter of if, but more when and how these ideas finally break through. Maybe they complement electric cars or find specific uses.
Perhaps. The fact that brilliant engineers like Jean Morel are still pushing hard suggests the dream of a better, simpler engine without a crankshaft is very much alive. In a world moving fast towards electric, maybe these find their place in hybrids or heavy trucks or aviation where batteries are still tricky.
Right.
Their success probably depends on hitting that sweet spot of technical maturity, cost effectiveness, and that ever-increasing pressure for greener solutions.
From Morel's magnets and coils back through Michel's swash plates and looking forward to things like photo detonation, it really is an amazing story of ingenuity. This quest for the crankless engine makes you wonder, doesn't it? What's the final piece of the puzzle? What specific combination of tech, timing, and maybe market pressure will finally let one of these designs really take off and change how we power things? That was a really fascinating look at crankless engines, and thanks again to the listener who suggested we dive into Jean Morel's work. If you enjoyed this and want to keep up with discussions on innovations like these, definitely check out Le Podcast de Philippe.
Yeah, some interesting stuff happening there.
And speaking of support, we are so close to hitting 1,000 subscribers here. Your help getting us over that line would be absolutely fantastic. So if you haven't already, please do hit that subscribe button. It really does make a difference. Until next time, keep being curious.